Hello, friends. Today we'll talk about measurement. So, measurement is very important thing in the research. So, here we have to keep in mind that when we talk measurement, it is a general measurement, whether it is science or arts or anything. Okay. So, measurement is here general term used.
With the results of that batch and calculate your earnings.
Okay. So when we talk about measurement, it is not only a measurement of physical objects, like we measure the length, we measure the temperature, we measure the height of the person, we measure the length of the object, but it is also a measurement of abstract concepts. Okay. So it is maybe related to psychology, related to the arts. Okay. So when we say measurement, so we measure maybe physical objects as well as we measure we measure abstract concept. Okay. In measurement, the process of assigning number to the object and observation. Okay. So what we do when we say measurement means we assign some numbers to the object or observation. Okay, so when we assign these numbers, there will be some levels of measurement, okay, and which is being function of the rules that rules we will understand later on, okay. So when we assign certain number to the object or observation, we use some function of the rules and then we decide that number. Okay. So for example, we can measure the weight. So in normal language, it is called as weight, but in technical language, we call it as a mass. Okay. Earlier, unit of mass and weight was same. But now in System International, the unit of weight is Newton and unit of mass is kg. So we'll understand here weight is the mass in a layman language. Okay. So we know that the mass or weight is measured in kg. Okay. So for that we use what is called as weight scale. We use this, suppose I want to measure the weight of person. So I will take the weight scale and measure. Okay, suppose the person's weight is 70, then I may choose 20, 20, 10, like this, 50, another 20, it is 70. Okay, but it is preset, standard weights are available. Okay, so that is our measurement. So we measure the weight of person, we measure the weight of object. Then comes the measurement of length, or we can say measurement of height. So we can measure with the help of the scale. Okay, we can use our scale, okay, for measurement or measuring tape, and then we can measure the height in the centimeter. So that is type of scale. So it is pre-decided scale. Okay, centimeter scale or measuring tape is pre-decided. Okay, it will not change. Okay. In some cases, like here, we can easily assign the number to the object, like length. Okay. But there are cases they're difficult to assign the number. Like you take the case of psychology, humanity. Like how will you measure the motivation to succeed? What will the scale? Ability to face the stress. How will you use the scale? Okay. Ability to solve the problem. Here, it is a difficult actually to assign the label or the scale. Okay. But it is very easy for the cases like weight or length, because it is already there, a pre-decided scale is available, which is accepted internationally, like centimeter, meter. It is internationally accepted. kg is internationally accepted. Okay. So we have high accuracy in measuring the pipe with the scale. But if the concept is abstract, measurements tools are not standardized and changes from person to person, changes from country to country. Please understand here. Okay. Here, understand that when we measure the concept, abstract concept, in that case, the scale is not well defined, well accepted. It will change from person to person. Okay. In physical sciences, engineering science, the scales are mostly developed, but not in the social science, psychology. Okay. Now, when we come to the research methodology is not, we can say it is restricted to the engineering science or any particular branch. So we need to understand what are the different measurement scales. So we'll see that there are the four measurement scales. Okay, first is a nominal scale, ordinal scale, interval scale, and the last one is a ratio scale. So they're in the increasing order of, we can say, best scale. Okay, so the ratio scale we mostly use in the engineering and science, and then remaining are not better. Okay, but they are used. Okay, so we'll start one by one. Nominal scale. So in the nominal scale, what happened? You might have seen the cricket team. You can see here the photograph. In the photograph, you can see that there is a cricketer Jadeja, and his number is given. Here we assign a number to each player. Okay. Here we assign a number to each player, but the number has nothing to do. It is just identification tag. Okay. Nominal scale, we assign a number to each player, but that number has no meaning. It is just the identification tag. Like my identification is Sachin. Okay. Does it meaning any value? Sachin is having any value? No. Same way, Jadeja is, you can see in the photograph, Jadeja is having identification number as 8. So it doesn't mean it is good or bad. It's just the identification tag. Okay. So what is the purpose of nominal scale is it is a convenient way of tracking the people. Here we can see in the match, or we can see the convenient way of tracking the objects, convenient way of tracking the events. Even you can see the buses will have some identification number. I'm not talking about the nameplate, but inside they will place that this bus number is this and this. So that is a nominal scale. It has nothing to do. It is only purpose is to identify. The number here, 8 number to Jadeja doesn't mean that it is in the rank 1 to 8. Okay. It is not indicating its rank. It is only identification tag. Okay. So that is called as nominal scale. Okay. So here the number is not having any, we can say, property, but it is only the identification tag. Okay. For people, objects, events. So what happens? It has become easy for us to track. Okay, tracking becomes easy for us. Okay, because of this. Got? We saw the first method of measurement scale. Now we'll go further. We'll see advantage and disadvantage of this. So, as the purpose of number here is only identification, we cannot do the mathematical manipulation here. Like we cannot find the average. What is the meaning of average? Nothing. It is just suppose there are 15 players in the team. So if you find average, what is the meaning of that? It is no meaning. Okay, because it is only the tag. Okay, so we cannot find the average just we cannot find the average just by averaging the 1 to 15 numbers. It will not meaningful. And we can also compare the numbers. Suppose number 8 and number 1, we cannot compare. It is a tag. Okay. Like Jadeja having the tag 8 is not higher than the person who is having the tag 1. Okay. It has no meaning. Okay. So it is just identification tag, we can say. So only one thing we can do, we can count number 1 to 15. It is just arithmetic, we can say operation, but it has no meaning. Okay. Now we go to the next scale. Then comes ordinal. So ordinal means what here? The meaning will be order. Order means they are in the some order. Okay, like lower to higher, higher to lower, but generally lower to higher. So ordinal scale places the events in the order. That will be in the order, like lower to higher. It will be in the order, lower to higher. So when we arrange this in the order, the gap between the two values, two events will not be equal. In ordinal scale, the gap between the two values will not be equal. Okay, but they will just arrange in the increasing or decreasing order. Okay. Now each value is while each value is ranked, there is no information that specified what is the differentiate the category from one to each one from each other. Okay, so we only know this is this person is having higher value, this person is having lower value, then this is lower than this value, like this. Okay, like I have given here one example. So I have not arranged in the increasing order but decreasing order. Like uh, placement in IIT Bombay. Student this year got one student got a package which is 3 crores. Then there is second student who got the package annual package of 1 crore. Then third student got the annual package of 40 lakhs. Fourth student got the annual package of 40 lakhs. Now, when I say ordinal scale, the first will be S1, second will be S2. So here we are not giving the information about its value. We're only saying S1 is bigger than S2, S2 is bigger than S3, S3 is bigger than S4. So we arrange this like, okay. So we don't know what is the difference between two values, but we only know the order. So it is ordinal, we can say it is an ordinal scale. Okay. It is an ordinal scale. Like S1 is bigger than S2 or S2 is bigger than S3 and S3 is bigger than S4. This order we know. Okay. And here the difference between the two values like S1 and S2, if you take the difference, it is different. If you take the difference between S2 and S3, it is different. If you take difference between S3 and S4, it is different. Okay. So we cannot find the difference between the two values because the gap between the two values is different. So we cannot values cannot be added. We cannot be subtracted. Only we know that there is a rank. Okay. So only we can say here that value of S1, or we can say the package of S1 is bigger than package of S2, or package of S2 is bigger than package of S3. That we know. But we don't know what is the difference between the package of S2 and S1. What is the difference in package of S3 and S2? Okay, it is just order mentioned. Now here I use a decreasing order, but mostly the people give the increasing order. Okay. So why I've taken decreasing order? Because we start with the number which is less. Okay. Okay. So we cannot say the exact package or difference in the package, but we know that there is S1 which is having the highest package, then comes S2, S3, S4. Okay. Got it? So that is called as ordinal scale. So we cannot do here arithmetic like addition, subtraction, because we don't know the difference between the two values. So the use of ordinal scale simply implies greater than or less than. Okay. Also, the equality statement is also acceptable here. Without our being able to state how much is greater, how much is less. So we don't know the difference, but we only know that S1 is better than S2 and S2 is better than S3. Okay. So we don't know to what extent it is better. Okay. That is called as ordinal scale. The real difference between now we take the case here. The real difference between the rank 1 and 2, which is here more than the difference between the rank 3 and 4. Okay, so the differences are not equal in the ordinal scale. So since the number of this scale have only a rank, meaning the appropriate measure of central tendency is median. We have already learned some statistics and we know the median. Can anyone tell me what is the median is? Yes. Can anyone tell me what is meaning of median here? Mean we know that we add all the numbers and divide by the numbers we have added. Okay. So what is the median? So median, we have already learned that what we have to do is we have to arrange the numbers in the increasing order or decreasing order. So if you select, suppose there are 5 numbers in increasing order, then middle number will be what? Median. So we find here the central tendency of the numbers by finding the middle number that will indicate the central tendency. We already learned. Okay. So we find central tendency here by means of median. We find the median, we arrange the numbers either increasing or decreasing order. We find the middle number, that is our central tendency. Okay. Now we'll go to the next scale. The next scale is interval scale. Next scale is what? Interval scale. So here the word itself indicates interval means what? The interval between the two numbers, difference between two numbers is equal. So we here also we arrange numbers in increasing order, but here we take care that difference between the two value is consecutive value or neighboring value is same. Okay. So intervals are adjusted here in terms of some rule. So there will be fixed difference between the numbers. Okay. So difference between two neighboring values will be same. Okay. Here we say that interval is equal or same. Okay. Now we'll take the case here, one example from the temperature measurement. So we know that we use in normal days we use for temperature measurement degree Celsius. Okay, so degree Celsius scale start with the 0 degree Celsius and then it goes on. Okay, so after 0 it is 1, then 2, 3, 4. I'll give a comma. Okay, first value 0, 3, 4, 5, 6, 7, so on. So difference between the consecutive value, if you find 2 minus 1 is how much? 1. If you find 4 minus 3, 1. So each consecutive value, the difference is 1 degree Celsius. So interval is equal. Okay. So please understand, when it is 0 degree Celsius, it can also go on negative side, -1, -2, -3, -4, so on. Okay, okay, we got this. So when we measure the degree Celsius, then the interval is equal between the two values, which is from 1, 2, 3, 4, 5. If you take difference between the two consecutive values, it will be same. So interval is same. Now we'll see one important concept here. That here we don't know where is absolute zero value of this scale. Okay, in degree Celsius, actually, it is not technical. You can say it is not technical temperature measuring unit. That technical temperature measuring unit is Kelvin. Okay, so how we find Kelvin is actually it is degree Celsius, which is small t plus 273. So this Kelvin is having 0 when Kelvin is 0, when degree Celsius is -273. When it is 0, when degree Celsius is -273 degrees Celsius. Okay. So actually, the degree Celsius is not indicating the true absolute zero. Okay. Zero is not actually zero or technically. Okay. So actual technical zero is k is equals to 0. Okay. We understood that. Now we'll move to next point. Now suppose we increase the temperature from 20 degree to 40 degree. So how much we are increasing? 40 minus 20, 20 degree. Now we increase from 50 degree to 70 degree. So here if you see the change in temperature when it is changed from 20 degree to 40 degree is 20 degree. When we increase from 50 degree to 70 degree, it is same. The change in temperature is same. Now we go about the scaling. So when we go for the scaling, it comes the problem. Okay. Now suppose we take the example like 60 degree and 30 degree, whether 60 degree is double to that of 30 degree. Whether 60 degree is double to 30 degree. Can anyone tell whether it is double? Yes. Can 60 degrees double to that of the 30 degree? No. Why it is no? Because it is absolute zero is different. Absolute zero of temperature is what? K is equal to 0 Kelvin. Okay. So I have just converted that temperature in degrees Celsius to the first Kelvin. Okay. 30 degrees what? We add 273, it becomes 303. For 60 degrees, we add 273, becomes, it is 333. Okay. If I take uh, Kelvin temperature 333 divided by 303, it is not true. It is very less. Okay. It is not double, we can say, temperature. It is not double temperature. It is very slight higher. Okay. So in the international scale, we don't know exact what is called as absolute zero. Okay, here I could tell you about this temperature because I am from the field of thermal engineering. I know that what is a zero, absolute zero of temperature. It is K is equals to 0 Kelvin. Okay. So scale is also characterized by the fact that number 0 is an existing variable. In the ordinal scale, 0 means that data does not exist. Okay. In the interval scale, 0 has meaning. Okay. In interval scale, the 0 degree Celsius can be the value. But in the ordinal scale, 0 is not having the value. 0 means in ordinal scale, it does not exist. Okay. But interval scale, 0 has the meaning. Okay. Like temperature can be 0 degree Celsius. Temperature can be 0 degrees Celsius. So scaling concept, multiplication, division is not possible in the interval scale. Like I've just taken the division of 333 divided by 303. So in degree Celsius, it is indicating that 60 degree, 60 degree and 30 degree. We obviously see that if we divide 60 degree by 30 degree, it is 2. But actually, in that case, the 0 degree Celsius is not actually 0 of that scale. Okay, for thermal system, the actual unit is what? Kelvin, and its 0 is at minus 273 degrees Celsius. Okay, please understand. So if you compare interval scale, yes, obviously it is better than ordinal scale. Okay. Okay. Because of the equal intervals, but still it is having some problem that will be taken care by next scale. Okay. So to indicate the central tendency, so we use here the mean. We know mean, we calculate the mean. Okay. And for dispersion, we use the standard deviation. Okay. We use the standard deviation for dispersions and mean to indicate the central tendency. Are you getting central tendency means what? Suppose we arrange the numbers 1 to 100 where the central number is indicating, okay, that we can find from the mean. Okay, we can find it from the mean. Okay. Now we'll move to the most appropriate scale, that is a ratio scale. we'll move to the most appropriate scale, that is the ratio scale. So please understand, please understand here, it is the interval scale only. It is the interval scale means what? The difference between the neighboring values, all neighboring values will be what? Same. And they will be arranged in the ascending order. But here, one fact is taken care that the scale have the absolute zero, absolute or true zero. Like I mentioned that now, here I will not mention the temperature in the degree Celsius, but I will mention the temperature in the technical scale, that is the Kelvin. I will use the Kelvin instead of what? Instead of degree Celsius, I will use the Kelvin. Because Kelvin gives the true center or absolute zero value, okay, which is minus 273 degrees Celsius. Now we'll see the examples which is having the true zero. Like the length. When we say length is zero means what? There is no length. It is absolute zero. When I say time, when time is equals to zero, means it is absolute time. From that time we measure the time. Okay. So we can conceive an absolute zero of length. Similarly, we can also see the absolute zero of the time. Okay. So we can see both. For example, 0 point on the centimeter scale indicate the complete absence of length. So I already mentioned. Okay. So the complete absence of length or height. But the absolute zero of temperature is unobtainable. So here it is mentioned that 0 Kelvin is not obtainable, but nowadays it is obtainable. Okay. Maybe it is old script. So they are mentioned. So absolute zero is difficult to obtain. Please understand, it is very difficult to obtain absolute zero of temperature. And the concept is, they are saying only imaginary. Yes, today we can obtain the absolute zero, but it is difficult. Please understand. Okay. So absolute zero concept is okay in terms of time, in terms of length or height, but it is difficult, as they mention, for temperature. Okay, it is difficult. Okay, it is difficult. Okay. Now we'll take now few examples where absolute zero is possible, like number of minor traffic violations, number of incorrect letters in a page which is typed. Okay. So number of minor traffic rule violation, it can be 0, it can be 1, 2, 3, 4, anything. So absolute zero is possible. Okay. Like same thing about incorrect letters, incorrect spelling in the type letter, we can make it 0, it can be 1, 2, 3, like this. Okay. So both of above examples have absolute 0. And such all the minor traffic violations, all the typing errors can be assumed to be insignificant. With the ratio scale involved, we can make the statement like Rona's typing performance was twice as good as that of Shonak. Okay. So we can really compare. The comparison was not possible earlier, like we took the case of temperature. Okay. So as there was no absolute zero for degree Celsius, So comparison like 60 degree and 30 degree, we cannot say that 60 degree is double to that of the 30 degree. But like in typing, when they type, you can find number of mistakes. Okay, like we compare the two-person Ronak and Shonak. And then suppose the Shonak makes more mistake than Ronak, then we can say that based on the number of mistakes, we can compare Ronak's performance with the Shonak. Okay. So ratio involved does have the significance and especially the kind of comparison. So what really the benefit of ratio scale is we can compare. Like earlier, it was not possible to compare 60 degree and 30 degree. We cannot say that 60 degrees Celsius is double to that of 30 degree because the degree Celsius scale is not having the true zero. But when it comes to the mistakes, we can find the mistake and we can count. When there is no mistake, it is zero mistake. When there are more than zero mistakes, then we can compare. Suppose Shonak makes 4 mistakes, Ronak makes 2 mistakes, then we can find the ratio, and then we can say that the performance of Ronak is better than Shonak. Okay. So the comparisons become easy with the ratio scale. Ratio scale represent the actual amount of variable where absolute zero is known. Like for weight, nothing is there means what? Zero. When something is there, so it will have some weight. Similarly, height, length we have seen, the distance we have seen, volume like this, okay? So ratio scale is a very famous scale in case of science and engineering. They generally take the absolute zero value in the scale. So all the statistical, the benefit of ratio scale is that all statistical methods we can use to with the ratio scale, and we can do the various analysis. So here ratio scale, when we find ratio means what? It is a division. So here multiplication and divisions with the ratio scale is possible. So even we can take geometric